So for example number 4, we're going to do another implicit differentiation. This time they've given us the mathematical equation x squared minus xy plus y squared equals 7. Now this one's a little more challenging because we're putting all the stuff that we know together. To differentiate that with respect to x, and I'm going to slide over a little bit here. This is going to become 2x, right? And then now this we use the product rule. So it's minus the first term, which is x, times the derivative of this one, right? So what is the derivative of y?
Yeah.
Y.
It's 1 dy dx plus, now we need the derivative of x, which is 1 times the original, which is y. Then we have 2y dy dx equals 0. Are you guys with me so far? So I've got 2x minus x dy dx plus y plus 2y dy dx equals 0. So now anything that isn't got a dy dx in it, this is dy dx. Any term that doesn't have a dy dx has to move over to the other side of the equal sign. So what I really have is I have minus x dy dx plus 2y dy dx is equal to negative 2x minus y. Okay, you guys with me so far?
Yes.
Now I'm going to factor out dy dx, and that's equal to, or when you factor it out, you're going to multiply by negative x plus 2y equals negative 2x minus y. And so when I divide both sides by that quantity, I get negative 2x minus y all over negative x plus 2y. Now, they gave us a point and they said calculate the slope of the tangent line at the point negative 1, comma 2. I think I said that wrong, but I meant it right in my head. We're gonna try to write the tangent line at the point negative 1, comma 2. And so the way that I find the slope of the tangent line is I have to plug in those x and y values here. Okay. The only thing is I think I made a mistake on the 2x. Did I write it down correctly?
Wait, because I'm kind of confused on like why you took the for like.
Wait, isn't it 2y?
Oh, you know what I did wrong? I forgot to distribute this negative sign through. So this should be a positive y, this should be a positive y, this should be a positive y.
Wait, isn't it 2y though?
What's 2y?
Because it's y squared.
What's y squared?
At the very
Yeah,
top?
here, yeah, this is y squared, so when we differentiate it, we get 2y dy
Oh, you
dx.
did okay.
This is product rule. We had to do the product rule here, so these two terms are from the product rule.
That was my bad.
Wait, I'm kind of confused though. Why did you separate? Why did you take the derivative? Why did you have the dy over dx for the x? I thought you were supposed to do that next to the y.
Oh, because it's the product rule. This is the product rule. When I differentiate x, y, I have to take the first term, which is x, leave it alone, and then multiply it by the derivative of the second term, which is y. Right?
Oh.
Right?
Oh, so you're doing like that
the product rule.
Oh.
Yeah, uv. So if I differentiate uv, then it's uv prime plus vu prime, right? So that's what this stuff is in the parentheses. So we're thinking that this is like u v, and so I have u v prime plus v u prime, right? Does that make sense? Now, I think in your textbook they write it the other way around, but with the product rule it doesn't really matter because you're adding, right?
Okay.
Mr. Adams learned it this way, and I'm always going to write it down that way no matter how many times I look in the book. Okay? But your textbook has it like VU prime plus UV prime, which with the sum it doesn't matter. Okay, so anyways, that's the answer. Now what do I got to do to find the slope of the tangent line?
Plug it in.
Plug it in. So when I get to, so basically to do the tangent line, what I need to do, I need the slope and I need the point. And the point we have because it was given to us as -1, 2. So my slope is really dy dx, which is really -2x plus y over -x plus 2y. What that really is, though, is -2 times x, which is -1, plus y, which is 2, all over -x, which is -1, plus 2y, which is 2 times 2. So when I do that, -2 times -1 is a positive, 2 plus 2 is 4. And then on the bottom, I get -1 times -1 is +1 plus 4 is 5. So that's the slope. This is the point. Now I'm ready to write the tangent. Well, that's going to be equal to y times m, or y equals m times the quantity x minus x1 plus y1, or 4/5 times x minus -1 plus 2, or 4/5 x plus 4/5. Now, how can I write 2 over? How can I make 2 over 1 be something over 5?
10 over 5.
10 over 5 or 14 over 5. So this, my tangent line is going to be 4/5 x plus 14 over 5. Now, how do I verify it? What am I doing? What am I saying? What are we trying to accomplish? Graph this. This is what it would look like graphically. It's kind of an ellipse that's tilted on the side. Okay, and so it looks like this. It's an ellipse that's kind of tilted, and it has the point here, -1, 2. And then the tangent line we said was going to cross through it was, that was y equals 4/5 x plus 14
Over 5.
fifths. And it works because they've graphed it on the they graphed it in your textbook, and so maybe Mr. Adams needs to find a little bit more robust graphing calculator as we start to proceed with this. So my question to you is, do you guys have any questions? You guys good on this?